Hello guys, you are welcome to my next tutorial. What we'll be looking at today is a problem on remove end node from the end of list, and we're going to approach this problem using list node. So given a linked list, you have to remove the end node from the end of the list and return its head. Now this is an example. Let's say we're given n to be equals to 2, and this is the list. This is a linked list. Now we're to remove the nth node from the end, so we're going to count 1 2. So we're to remove this node 4, and we'll return 1 2 3 5 as a linked list. So if we are given n to be 1, then we remove 5, we return the rest. If we are given n to be 3, then we count from the behind, we return this 3 and return the rest. So now there are different ways you can approach this problem, and you can assume that the n will always be valid. That is, the n will always be within the range of the size of the linked list. Is it possible to do this in one pass? Yes, but we're not implementing that in this recording. Maybe in our next presentation we might look at that. But let's, in either of the two ways, we still have to traverse the entire linked list in the worst case, and that is still going to give us a linear time. It's going to give us a linear time complexity. So let's look at it using this example. So to approach this problem, the intuition is, before I can delete the second element from behind, I need to have a way of getting to know that I am at that position where I need to do the deleting. And so, since there's no way for me to be able to know the size of my linked list, the only way is for me to go through the entire list first. After I've gone through the entire list, then I can take a recording the length of that list, and once I get the length of that list, then I will subtract my n from that length, and from there I will be able to know where I need to do my deletion. And so that is the idea that is implemented in this presentation, and that will take us to walk through it, to walk through the entire list twice. The first time we have to walk through counting the number of nests that we have, so that we'll be able to get the length of the entire list. And after implementing that, we have gotten the length. The next will be for us to iterate through until we'll be able to get to n, the length minus n. And once we do that, we'll be able to find where to do our deletion. So in both cases, the first time we go through it n times to get the length. The second time we go through it almost n times, depending on what the difference is. Depending on what the difference is, so it's going to be L minus n. So that is what we're going to go through it in the second time. All right. So, but if you want to implement it, that you don't want to get, if you don't want to first of all get the length, an idea could be that if you start from the head of the list, you will need to keep checking at every point you will need to keep checking at every point the number of nests, whether it corresponds to your n. That's just an idea which you can implement, but that's not what is achieved in this presentation. But if you don't want to first of all get the length of the list, then you want to do the whole thing in just one pass. Then when you get to the head and you know you want to delete the second from the end, you don't have idea of how long this list is, you don't have idea of how long it is, so and you don't want to continue to pass, because in linked list is just one direction. Once you have left the head and you have moved to the next one, there's no way for you to get back here. You can get a pointer to the next, to the one that is still in front, but you cannot go back. There's no pointer for you to be able to reference the one behind, the one that you have left. So for you not to miss what you need to delete, then you will have to, at each point, you have to keep track of what is in front of you so that you can do that deletion. So you need to keep track. So for instance, if the length is 3, for instance, if we just have 3 nodes, then when you're, and your n is 2, when you are here, you need to quickly keep track and check your next, because you are deleting 2 from behind. So you need to keep track and see whether you have reached the end. And when you have reached the end, you know that your .next is going to return a null. So that's the idea. So you have to keep track that your next is null, and when that is null, so in that situation you will need to use a kind of while loop, because you don't know how long you will have to iterate. So you need a kind of while loop, and that the while loop will run continuously through, and you will have to have a way of specifying break in your code when you have reached to where you want to delete. So you will have a while loop that runs continuously, and once you are here, let's say you're here, your while loop is going to continue to check the number of times. So say for instance, if your n is 2, I think you can even use a for loop. If your n is 2, you can do like take a for loop and initialize your for loop to run 2 times, to run in less than 2 times, in less than the number of times of your n. Just you want to check whether you are able to delete. So if you run a while loop, in that sense, if you run a while loop for, in this case, your n is 2, so you are going to get the head.next. You get the head.next. You want to try and see whether it's null, so you do like a comparison. So the first time you get the head.next, okay, whether it's null. The reason why you're checking whether it's null is you want to know whether you have reached the end of you have reached 2 elements to the end of that list. It's very interesting. You're trying to check whether you have reached 2 elements to the end of that list. So you check head.next is null, okay, then you go again, you check, because you have to replace your head will become head.next each time. You have to update your head to be head.next. That means you are moving from here to here. So this become head again, then you move again to here. So each time you run through this and you check your head.next is null, then you make your head to be head.next. Then you go again, head.next is null. Then if you are able to discover at the end of this number of iteration, if you are able to get a null, then you know that you are 2 elements away from behind. Then you can do your deletion. You can do your deletion in your code. You can try that. But in this implementation, what we have is, this is in Java program. So you have remove end from end is receiving a list node and the position from behind of the element of the node that we want to delete. So first is we declare another method called getLength, which you will see, and that method will give us the length of the linked list. We subtract n, which is where we want to delete from behind from our linked lists. Then we assign that to position. We're going to need a pointer, we're going to need a temp, and we are returning head2 as our new head position, like it's required of us. So first we make our head2 to be the head that is given us. Alright, so we iterate through the position. Since we know the position, if getLength is 5 and n is 2, then we have to go through it. So we have to go through it, that is 3 times. So since we are starting from 0, to be less than position, so we iterate through the number of position, and each time we are iterating through the number of position, we update our pointer to be the head, and we update our head to be head.next, just like I explained in the previous case. So that you can keep moving, you can keep moving and keep moving. And once this for loop finishes, that means that at the termination of this for loop, it means your pointer is now referring to the head. So your pointer is now, the pointer is now the current head. So if the pointer is the current head, we check if the position is 0. If position is 0, then it means what you want to delete is the head. You can do that math. So if you have 5 nodes and you give it n is also 5, then you have 0. That means you are deleting the first node. And so if you are deleting the first node, what you just need to do is make your returned head to just be head next. So if you have this case, you have this, you have this, and you are deleting this, so all you just need is make the new head 2 to just be, because the next of this head, if this is your h and this is your h2, the next of h is this. So what you just do, you make your h2 to be equals to this one. That's all. So by so doing, you have gotten rid of this. Else, if pointer.next is equal to null, if pointer.next is equal to null, that case means you are actually deleting the last element. You are deleting the last node in your linked list. Let's say you have this. This is the one that will give you pointers. So because this is your current pointer, and the next of this one is null, so that means you are deleting this one. And so if you are deleting this, if pointer.next give you null, and that means this is what you are getting rid of. This is where your termination landed, and that means this is the node to be deleted. So all you just need is just set that node to null. That's all. Once you set it to null, it's gone. Else, then if you are not deleting the last node and you are not deleting the head, then it's any one of the one in between. And so in that case, you can just use pointer.next to store that in temp and make your pointer.next to be equals to temp. And that's very tricky, but it's simple. All that is just saying is this: I know that I am not deleting this, I know that I'm not deleting this, so I'm deleting any one of these ones. So what I do is that if my pointer terminates here, if my pointer should terminate here, let's say for instance maybe my pointer terminates here, you can check that. If my pointer terminates here, then I'll check my pointer dot next is this, dot next is this. So I am making my temp to point to this. Okay, so this is my pointer, is next is this, is second next is this. So I'm making my temp to point to this. Then I am now saying pointer dot next. So this is a pointer. I am saying pointer dot next. It should now point to temp. So if I now set pointer dot next to temp, so this is my pointer. This is my pointer dot next, and I'm now setting it to temp. So by so doing, I've gotten rid of the one in the middle. Let's look at that clearly. So let's say for instance I have this, 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 this. Now if my pointer should terminate at this position, if my pointer at the end of my for loop, I get my pointer to terminate here, then I'm initializing my temp to be equals to my pointer dot next dot next. So I am initializing this already. This is the one that I want to delete. This is the one to be deleted. So I'm initializing this to be, I'm initializing temp to be this pointer dot next, which is this. Now I am now making pointer dot next, which is supposed to be this one. I am now I'm not setting it to be this. By so doing, I have gotten rid of this. So that's the point. That's the point there. It's very tricky, but you can take time to look at it. First, you store two ways, two nodes away from your current pointer. You store it in a temp because you want to get rid of what is in front of your pointer. So you store two nodes away from your current pointer into temp. Then you now make your temp dot next. You equate it, instead of your pointer dot next to be equals to this one, you equate it to this one. So by saying you got to rid of, that's the idea that then you return x. I just do this is our get length. Get length is interesting, but it's tricky. Just as long as you continue to have add.next, if it is not null, you have a counter which started with 1 because you have at least add, and you make your add.next to be head. At the end of the day, you just return your I. You can look at this very well. It's tricky because you need to continue to go to add, continue to go. The only time when you are going to have add.next to be null is when you have reached the end. So at that point, that means you have exhausted the number of nodes. You have counted all the number of nodes. So this will terminate when head.next is null. And since you're starting from 1, then you get the correct counting. You can try that. You can find the code on our GitHub page. The time and space complexity, the time is n, the space is constant. And thanks for listening. You can just do a quick walkthrough of the code for us to to have a feel of what we have on our GitHub page. So this is the code, full-fledged code that we have on our GitHub page. I've just tried to create a sample list node. A head is add one, current to add next current. So just created some sample list here of 1 2 3 4 5, and so created an object of list node 2 test, print that out here, and so this is what we walk through. So here I just after I've created the linked list, I just try to create an object of linked loads underscore 2, which is where we heard this, and use that object test to get the length of our head, because this is the head that we just created. So use that to get the length of our head. So this should give us 5, and then we remove the fourth element from behind. So if we remove the fourth element from behind, it returns back the head, and we get the length of the return head, which should give us 1 less. And so that is what we have in our code. So you can just run that by saying javac, and java. So you can see length 5, length after deletion is 4, and if we decide to just delete to give the deletion 0, that means we are not deleting anything. So we expect the length and the length to remain the same. So you can just see that. So the length is 5 and the length is giving us 5. So nothing has been deleted. And if you want to delete the head of the element, then that will be 5, because that is the first element. So if you want to delete the head, you can verify that by the time the head is deleted, what will be returned, it will be 4 notes. Thanks for listening. See you in our next tutorial.